Okay, so in this video, we are going to discuss some NUST entry test past paper questions which are related to the topic permutations, combinations, and probability. So let's get started. Right, so this is the first question. That is 0 factorial equals. Now, what is factorial? Let's say if we have 3 factorial. So 3 factorial is defined as 3 into 2 into 1. For example, if we have, let's say, 5 factorial. So how do we define 5 factorial? 5 into 4 into 3 into 2 and then into 1. Okay. So we start off with this number and we end at 1, right? So in case of 0 factorial, at times students end up saying that 0 factorial means 0 and we don't have any number less than 0 that is positive. So this is that the answer is 0. No, it is not like that, okay? 0 factorial is defined to be 1, okay? It is a definition. You can check that on your calculator as well. For 0 factorial, we don't use our usual definition. So the usual definition only holds for all the positive numbers, and for negative numbers, we cannot define factorial, right? So 0 factorial is not 0, 0 factorial is 1. And for all the negative numbers, we can't define factorial, right? So we can't find factorial for that. You can even check that on your calculators. You will get the answer. You'll get an error for that, right? Okay. Let's talk about the second question. Then we'll get better at factorial. So we have 4 factorial plus 0 factorial. Okay. So what is 4 factorial? We have to start with 4. Then 1 less than 4 is 3. Then we have 2 and we have to end at 1. So we are done with 4 factorial. Then we have plus and then we have 0 factorial. That is 1. Okay, we just defined that 0 factorial is 1. So this is going to be 4 into 6 plus 1. That is 25. So the answer is C. Now, obviously, in NET, you guys would not be allowed to use calculators. So you need to be good at mental maths, right? So this is why I do all these extra steps. Okay. Let's talk about the third question. N plus 3 factorial divided by n plus 1 factorial is, okay. Now we don't know what n is, so we can't write down the full form of n plus 3 factorial, right? But we can just simplify the numerator and denominator accordingly. So I have n plus 3 factorial, that would be n plus 3 into n plus 2 into n plus 1 factorial, right? For example, if I talk about 5 factorial, so I can write this as 5 into 4 into 3 factorial, right? I can always write 5 in this way. Similarly, if I have n plus 3 factorial, I can write it n plus 3 into n plus 2 into n plus 1 factorial. And why am I writing it this way? Because I have my denominator as n plus 1 factorial. So I can always cancel it out. This is going to give me this. So I can just cancel these two out and I have n plus 3 and n plus 2. Now, obviously, when we have n, when we have an unknown number, we are not sure about what exactly would n be, right? Because it is unknown. We don't know the value of that. But what we know is that for any factorial, let's say if we have 6 factorial, I can write it as 6 into 5 factorial, right? So since I had n plus 1 factorial in the denominator, I wanted n plus 1 factorial in numerator as well, just so I can cancel those out, right? So B is the answer. Okay, let's continue further. Let's talk about the fourth question. Okay, now we have NPR. Right. Now, this is basically a definition. Now, obviously, why this question is important, some students might say that this is a very easy question. In NEP, you will have a variety of questions, right? Right. By variety, I mean their difficulty level would vary from question to question. For some questions, you'll need seconds, and for some questions, you'll need more than 3 minutes, right? So you have to be very careful while allocating time, right? So NPR is basically what students do on calculator. Like they have a button. So let's say if they are interested in finding out um, 15 P5, they just use their calculators. But why is it important from NET point of view? Because calculators are not allowed, okay? So you have to know how to find out the value of NPR without calculator, okay? So the general formula is for N, P, and R. This is how we find it out. It is N factorial divided by N minus R factorial. Okay, so this is how we find NPR if we don't have calculator. So the answer is D. And this is a formula, but yes, it is very important from NET point of view, because if you don't know this formula, you will it could be that you are not able to answer 3 to 4 questions which are related to NPR and NCR. So that is important, right? Okay. And then we have the fifth question. Okay, so for the fifth question, we'll be using this definition. Okay. Fifth question is 7p7. Okay, we need to find the value of 7p7. It's very simple. Obviously, you can't do it on your calculator. We need to use this. So if we have 7p7, it means that n is 7 and r is also 7. So 7 minus 7 and then factorial of this answer. So this would be 7 factorial divided by 0 factorial. Now what is 0 factorial? We have been discussing that 0 factorial is not 0, 0 factorial is 1, okay? So this means that the answer is 7 factorial, okay? And how do we find that? 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay. Now again, you have to do this calculation without calculating. How are we going to do that? Pairwise. 7 into 6 is 42. Then 5 into 4 is 20. And then 3 into 2 is 6, right? Then 42 into 20 is easy. It is 840 into 6. And yes, for that, we need to multiply that. So the answer is 5040. If you multiply 840 with 6, this is what we are going to get. Okay. Then we have 15p5. Okay. Now for this question, again, we need to use the same formula. What is the formula? It is n factorial, that is 15 factorial, divided by n minus r factorial, that is 10 factorial. Now this is 15 into 14 into 13 into 12 into 11 into 10 factorial divided by 10 factorial. And why am I going till 10 factorial in numerator? Because I have 10 factorial in denominator, right? So I know that I can easily just cancel these two out and I have to multiply all these. Now, how do we do this? Okay, so 14 into 13 is 182. 12 into 11 is 132. And this is 15. Now again, you need to multiply it 2 times. And the answer is this. Okay, so obviously these questions are easy. But yes, the working And the simplification is a bit difficult because you have to multiply it without calculator. So that could be a challenge. Okay. Sorry. Then we have the seventh question. How many signals can be given with three different flags when any number of them may be used? Okay. Now we have three different flags and any number of them may be used. Okay, so we can use three, we can use two, and we can use one, right? But what is important? Different is important, right? So they should be different. So we can have one, we can have two, and we can have three flags, right? So if we have one flag only, obviously, since we have three different flags, so we can have three possibilities, right? Because let's say if we have red, green, and blue, and we have been asked to, you know, give three different flags. So yes, in that case, since the number of them does not matter, we can have one at a time. So for one at a time, we can have red, yellow, and blue, right? And then for this, we will have, if we have two flags, we can have three into two. And if we have three flags, we can have three into two into one. Okay. So this is 3 plus 6 plus 6. That is 15. So B is the answer. Now in this question, we only have two keywords. Okay. 3 different, right? 3 different. And then the second keyword is any number of them, right? So we can have one, we can have two, we can have three. So that is going to change our answer. Okay, so if we have one only, we have three possibilities. If we have two, we have six possibilities. And if we have three, again, we have six possibilities. Okay, and why do we have two and one here? Why can't we write three into three into three? Because we need different. Okay, we need to have a different color every time. That is why we need to minus one from the previous number. Okay, so the answer is 15. Right, now let's talk about the eighth question. In how many ways can four books of Urdu and three books of Islamiyat be placed on a shelf so that the books on the same subject are always together? Okay, so we have four books, right? We have one, two, three, four books of Urdu, and we have three books of Islamiyat. So we have one, two, and three. So in total, we have seven slots, right? We have seven slots, and we need to arrange these books in these slots such that books on the same subject are always together. Okay, now we only have two options for that. Either we can keep the Urdu books first and then the Islamiyat ones, or what we can do is, again, we'll be having seven slots, and in this time we can have Islamiyat books first and then the Urdu books. Okay, so if we have Urdu books first, we are going to have 4 into 3 into 2 into 1. And if we have Islamiyat books first, so we will have, and second Islamiyat books, we will have 3 into 2 into 1. And then if we have Islamiyat books, so we will have 3 into 2 into 1. And if we have Urdu books, we will have 4 into 3 into 2 into 1. Okay. Now what you need to understand is that here we are again trying to make different arrangement. Okay. But every time the scenario is different. Now this time they want us to put the same subject books together. Now we have two subjects. So the only possibilities are like two. Either we can have Urdu books first and Islamiyat books after the Urdu books, or we can have Islamiyat books first and then the Urdu books, right? Now first we need to see how many arrangements can we make for Urdu books. So we have 4 books in total. So this would be 4 into 3 into 2 into 1. And for Samya, that would be 3 into 2 into 1, right? So this is the first option and this is the second option. We need to sum these up and then we are going to get the answer. So this is going to give us 4 into 3 is 12 into 2 into 6. So this is 12 into 2 is 24 and that is going to give us in total 144, right? So if we have 144 for the first possibility, for the second possibility, if you look at it carefully, we have same numbers that are being multiplied but in a different order. So that would also be 144. Okay, so if you multiply it once, you get 144, and then you don't have to multiply it again. We just have to sum these up, and this is 288. So again, we only have two possibilities, but yes, in each possibility, we will have 144 options because we have 4 Urdu books and 3 Islamic books, and we can arrange them whatever way we want to, right? Okay, but the only condition was same subject books are always together and nothing else. So we can do it this way, right? So now we have the ninth question. So this is NCRS. Now again, this is like NPR, but this time around you don't have your calculator. You can't do it on your calculator. You need to do it on your own. So you need to know the formula. So in general, NCR is basically n factorial divided by r factorial into n minus r factorial. So the answer is D. Because in D we have n factorial divided by r factorial into n minus r factorial. Okay. Now let's talk about the 10th question. In the 10th question, we have 4C4. Again, we'll be using this formula. So if we have 4C4, this would be 4 factorial divided by 4 factorial because r is 4 as well. And n minus r is 4 minus 4, that is 0 factorial. So this and this can be cancelled. We have 1 and this is also 1. 0 factorial is also 1. So we have 1 by 1, that is C. It should be 1. Right. Okay, so we are done with this. Now let's talk about the 11th question. How many even numbers of 4-digit number can be formed from the digits 1, 2, 3, 4, 5 if repetition is permitted? Okay, now we have a 4-digit number, right? So we can make 1, 2, 3, 4 dashes. Okay, and you guys must be noticing this is how I'm doing every question. So let's just stick to one method just so we have one method and we can solve every question that way, right? So we have 4 dashes and the choices are 5, 1, 2, 3, 4, 5. Okay, and what is the condition? Even number. Okay, now for even number we know that we need to have an even number here at the end, right? So in our options in 1, 2, 3, 4, 5, in these 2 and 4 are the only two even numbers which we have, right? So I can write 2 directly here because I only have two options for this last slot. One is 2 and the other one is 4, right? Now for the first slot, I have obviously 5 because there's no condition for the first slot, and for the second one, again, I don't have 4. I have 5 options because repetition is permitted, right? Because of this thing, I can write 5 here and then 5 here as well, right? There's no point in writing 5 into 4 into 3 because we do that when we don't want to repeat anything, right? But here they are telling us that repetition is permitted. So we need to find the maximum number of even numbers of 4-digit numbers that can be formed. So this is going to be 25 into 10, that is 250. So the answer is C. Okay. Now let's talk about the next question. Okay. So the 12th question basically is, the statement is not that visible, but the statement was the number of diagonals of a 12-sided figure. Okay. Now for this, we again have a formula. The reason behind sharing such questions was just so we can discuss all the formulas as well. The statement was the number of diagonals of four-sided figure is. Okay, so we can only imagine a four-sided figure, right? So in this case, we do this way that we have one diagonal and then we have another one. Here they want us to find the number of diagonals of a 12-sided figure, right? So we can't imagine that. We can't start drawing that because that is not easy. So we have a formula, right? In general, let's just rub this. We have number of diagonals of n-sided figure is n into n minus 3 divided by 2. Okay, now you should learn this formula, and obviously in question it's not necessary that they give you 12. They can give you 15, 13, 11, 5, 0, not 0, but yeah, 3 would be minimum and so on. So if we do it for 12, we are going to get 12 into 12 minus 3, that is 9, divided by 2. So this is 1. This would be 6. So 6 into 9 is 54. So the answer would be 54. Okay. Now, obviously, forget about how many minimum number of sides we can have. We can talk about squares, we can talk about rectangles, in general, we can talk about quadrilaterals, but don't think like this, okay? Number of sides would be given in question. You just have to use the formula and tell the number of diagonals, right? Okay, so we are done with the first part of this video.